Okay, I think we're ready to go. See if we can get through this presentation without Microsoft software doing something odd. The last one, halfway through the presentation, it started a tutorial on how to use PowerPoint. Just clicking through the slides. So, a couple of words about this, this presentation. So, how many of you guys are Motorglider pilots? Pretty good number. How many OSTIV members? Oh no! I should join OSTIV.
Is this also for like sustainer engines? The same thing?
Yes. Yes. So a lot of you Motorglider pilots, as am I, we all love the flexibility and we wouldn't trade it. However, we also, if we've been flying them for a little while, know that they're a little bit difficult in reliability. And they work just well enough that we trust them, start to trust them and start to fly as if they are going to continually work. And then it goes from a reliability problem to a safety problem. So I'm going to quickly go through a bunch of common design errors, and I will try to defend all manufacturers equally. And then I'm going to talk about, perhaps what to me is more interesting, is the systemic reasons why this happens, continues to happen, and will continue to happen unless we do a few things differently. So that's why we're here, not to pick on anybody, so please take this in the spirit in which it's intended. And let's see if I can, oh yeah, we're starting to turn it on. Okay. So how many of you have read the Prires survey? You guys know what I'm talking about? Okay, there's a link on my website. This is a really important survey. It was done 12 years ago. It's just a sample survey to a number of Motorglider pilots. 30% of the pilots surveyed had an engine failure after having performed a successful test run at the beginning of the flight, and 30% had damage to the aircraft as a consequence of operating the motor. That survey is a bit old. It needs to be redone. We'll talk about that, but the stats haven't changed all that much. And again, a reliability problem becomes a safety problem when people rely on this stuff. We are used to Toyotas. My last car, I rolled over 207,000 miles when I traded it in for the current, never broke down. And that's the expectation that people have when they buy equipment, and we are pretty clear that that's not what we get. But again, when people rely on it, then it becomes a safety hazard. We have a lot of accidents where pilots are not treating landing as plan A. In-air restarts require safety, starting the landing pattern, getting everything set up and planned, then try to start the motor. It starts wonderful. And when it doesn't start, finish the landing. We have a major training issue because this stuff isn't standardized, isn't well taught, and so people keep making these mistakes. For me, when the motor runs and nothing breaks, I'm fairly well astonished. And especially with the gas-powered machines, rather than do pre-flight inspections, we're doing post-flight inspections because we want to catch whatever broke and fix it prior to the next flight. When we don't do that, we just get unfortunately surprised the next time we go to fly. We talk a little bit about electrics. Everybody says, it's electric, it can't possibly be unreliable. It's just a motor. What could possibly go wrong? Well, we'll talk about that and some reliability stats that I have. And again, systemic problems that guarantee the way that we're doing things will continue to have reliability problems. The most common difficulties we have to do with vibration-induced failures. Not so much with the wankles, not so much with the electrics, certainly with the recip engines. High power to weight, high vibration. Exhaust cracking. How many of you guys have had an exhaust crack? And the rest of you don't admit it. Okay. Structural cracking. How many people have had a part of the main structure or the extension or retraction system crack? Now, these two pictures are a spindle drive system where the drive attachments cracked or broken completely through. And then electrical leads. folks have had problems with electrical leads vibrating and breaking. Yeah, oh, lots of them. Okay, so that one's real common. Ignition coils are real common. Generator coils are real common. Switches, especially magnetic, they have very, very small, fine wires inside there, and they tend to fail. And the linear actuators that are used for pylon extension also have coils with fine wires coming off the coil, and internally they're often not well supported, and they fail. One of my pet peeves is stupid tricks with limit switches. Everybody's seen these before? The hinge on this is this little plastic nib. The actuation leverage is this distance, the ratio of that distance to the ratio of that distance, right? To hinge. But the lever, surprisingly enough, has leverage. And more important to think about than the actuating leverage is what happens when you apply a side load to that thing. Well, the little plastic thing, you've got the leverage from a side load up here. So the ratio of that load to that load, right? So it takes a tiny side load to start eroding this silly little plastic nib. And so what happens is people install these things, the load isn't perfectly controlled, and they break. How many have had one of these micro switches, hinge disappears or breaks? Really? Nobody here? All right, well.
Disappeared, you can't find it.
I'm sorry?
Disappeared, you can't find it.
Yeah, it's just, you look in there and there's no, it's gone, right? Well, what happened? It just loaded on the side and popped off. Another stupid limit switch trick is installing the switch so that the direction of motion is, the switch is opposing the direction of motion. So for example, a engine pylon coming down like this, right? Just directly on it. But what happens if it goes past the intended travel? Smashes the switch, right? How many have had that happen? What, am I just lucky? People don't want to admit it. Another thing that people do is they put a slug on a cable or an actuator or a lever or something that slides past that thing and actuates it. Well, if the slug extends past the expected area of travel and you have a square end on the slug and then you push it back, boom, right? How many people have had that happen? Come on, guys, I must be incredibly lucky. So that's a real common problem. Poor choice of limit switches, as in little plastic hinge, poor actuation schemes, poor installs lead to a lot of failures. So how many people here have had engine failures due to a micro switch failing somewhere? Okay, so a few more people admit it. One thing is you can use redundant switches, but unless you get into 3 of them and voting, and you can cause more problems than you solve with that. Okay. Anybody recognize this one?
Oh, yeah.
You guys know what happened?
Switch.
So the primary cause of this accident, to be absolutely clear, was the pilot trusting the motor. And doing that is just asking for trouble, electric or otherwise. So Sebastian Campo was kind enough to send me this. And he also sent me this one. Okay. What happened there?
The arm broke off.
The arm is gone, right? Why is the arm gone? Because there's a side load on the switch. How many design errors can you guys spot in this picture? Anybody? Other than the switch. What else is wrong with this picture? Hmm? The wiring isn't well protected, right? What else? Okay, look at this installation. It can rock this way. Yeah, it's not well controlled. Look at that bend. It's not strong enough. It can easily bend one way or the other. So you're going to have, even if the switch doesn't break, you're going to have unreliable actuation. So GT has changed this, and I believe they're now using magnetic switches. So before we talk about that, here's a belt and suspenders installation. This is actually the engine bay door for my Antares. So a few things. First of all, that switch, it's a lot heavier duty. It's not humongously heavy duty, but it has a lot more material here. The hinge is actually a piece of metal, and this larger piece piece of plastic material. You could still erode it if you side load it. The roller on the lever makes the side loading less problematic and ensures that there's no excess force on the thing. The way that this mechanism is designed, so even though this hinge is moving in and out, right, the actual pivot point is here, right? So as the engine bay closes, this kind of goes down and in, right? This keeps the actuation in the proper orientation with respect to the switch. The leads, somebody commented on the leads in the other picture, properly heat shrunk, and they're supported back here. The actuating slug cannot go past the lever, and both sides of the slug are tapered. That or I can't see the side that's installed upside down, in which case I have a different problem. Anyway, this works very well. So it's a little more complicated, a little more cost and complexity, but it's not going to fail. Okay, so people say, this is terrible, these silly little limit switches. Let's use magnetic. What could possibly go wrong? Anybody? Okay, fuzzy actuation point. It's not click, click. You don't have a fairly tight tolerance towards the actuation point. So you have to design for a pretty wide range of actuation. Permanent magnets that are used for these things are not permanent. If you go buy a cheap magnet, it decays over time. So the actuation point changes. And the sensor leads, again, this is, how many people have had this one fail? Yeah, 1, 2, okay. So what happens here is you have these very small leads coming off the sensor, and in this case, this beautiful looking part, the leads inside here were not properly supported to sustain, to survive vibration. Fires are bad. A lot of the fires we have are maintenance rather than design. The most recent fire that I know about a couple months ago out in California was a belt roller had the bearing blow out. If the guy had been inspecting it properly, he would have caught that before it happened in flight. All right, this is a design error case, not a maintenance case. In the early days of it's now Austro installations, there were a number of these. So what happened here was this is the exhaust shroud. The fan mechanism is up here, right? Pushing air back and around, out. Yeah, is that the way it works? You guys have these things, I don't. Anyway, that was a flammable material. Oops. And I don't think there was an AD on that. I think, various people found out and replaced it, but hopefully all the old ones out there have now a non-flammable shroud. Another thing about fires is in most cases the fire warning system did not work. So that's now some potential area for us we'll talk about in a little bit. This one, I actually wasn't able to track down the details of this one. This is a Nimbus 4DM that caught fire during takeoff, and I don't know if they got the fire warning or somebody called them on the radio. They landed straight ahead on the campus. It was in mid, right? And jumped out of the plane and ran away as it burned. Anybody remember this one? This is a Vision Jet. This happened like a couple of weeks ago, 3 weeks ago. And the point of including this slide is this fire started in the electrical panel of the audio mixer panel. So the point is it doesn't take much. And if you don't have really high standards throughout, you can, even in the case of this, which is a very tightly controlled, well-engineered, certified aircraft, you can have this kind of outcome. And ours do not have the kind of certification and engineering that these things do. Okay, anybody recognize this one? Nice, huh? Oh yeah, you do recognize that, okay. So here we're using a, shall we say, non-standard fuel line, spring in the middle to prevent it from collapsing, except the spring doesn't go to the end. And then it's nicely hidden by a piece of protective thing. It looks all very beautiful until you take it apart and find out why the engine isn't running. So we have a long history of Motorgliders using very odd parts, not aviation parts, for fuel systems. This applies to fuel bladders, connectors, and hoses. And this continues. This one is a relatively new 29 ES, delivered at the beginning of last year, I think. Anyway, it took a long time to find that problem. Another thing we have different manufacturer where you have the engine moving on a pylon. So they've actually gone to a pretty high sophistication fuel line with braided protection and everything. And this thing was hidden, so the guy couldn't see it during pre-flight, but eventually what happened is, as the pylon is going up and down, it's eroding, it's rubbing, and then the vibration of the thing is rubbing. Went right through the braid and made a pinhole in the fuel line, so fuel was presently gushing out of the fuel hose. I didn't collect a bunch of pictures. We had a history of propeller and drive system issues. The most common one is belts breaking. How many people here have had a belt break? Yeah, a few. Okay. Fortunately, propellers departing the aircraft are not that common. How many people have seen one where that happened? No. The hub is not designed and fabricated for the fatigue loads that these things encounter. And designed in case of loads and fabricated in case of, if you have high loads flexing like that, you better not have surface scratches that turn into cracks that propagate through and then the property parts. This happened a lot with the DG1000T and the Antares 18T. This is a very unpleasant thing here. How many people in this audience, I saw at least one, have had the ring gear slash flywheel depart the crankshaft and start bouncing around while spinning at 7,000 RPM in the back? I know there's at least one person in here. Okay, well, nobody wants to admit that. Okay, so engineering for that kind of stuff. Again, because of the extremely high cyclic loads on these things, every time the cylinder fires, it's accelerating, and then it's decelerating, and decelerating. That causes cyclic loads on all the structure, and it also causes flapping on the prop, as the prop is accelerating and decelerating. Right, so you look at the thing and you think, oh, it's just running at a constant RPM. Well, it's not. It's vibrating like crazy and trying to tear itself apart. Fabrication errors, this is kind of a curious thing. We have a lot of problems with quality control, but sometimes it's also a design issue. So for example, this picture, what happened is this bolt was stopped, was hard stopped into the threaded hole here, but it wasn't deep enough, which means this part was not at all restrained, which meant that during the normal shaking of operation of this thing, it fretted. I only spotted it because I saw some suspicious black oxide. So it's a combination of a design error, fabrication error, not catching the fact that it wasn't actually clamping the part. Another favorite. How many people have had a failure of your electrical harness due to a connector assembly failing? Oh, lots of people admit this one. Okay. This is a little hard to see. This took me a really long time to find. If you look at this picture, everything looks pretty much right. If you look at this picture in the mirror very carefully, what's wrong with that?
Can't see the star.
Funny thing, something's missing there, isn't it? See that? No gold. So a very common error is the pin is not fully inserted. So you take the wire, you take the pin, you take the special crimping tool, you crimp it, and you push it until it goes click. If it doesn't go click, that's what happens. This burned mess was also a consequence of the pins in the connectors not being fully latched in. And it ended up with this fairly high current flowing through this thing, and so you ended up with this mess. Pin incorrectly crimped on a wire. How many people have had a failure where the wire came out of the end of the pin because it wasn't crimped on properly? Fair number of people. Okay, so this is stuff that ought to be caught during manufacturing. Lead insulation, strain relief, and support. These are all kind of interrelated. How many people have had the wire fail right next to a switch assembly or a connector? Yeah, okay. If you don't properly support everything, you get, and especially if you have a very sharp end in the cable right near the connector, you're going to stress the thing, and before you know it, you have a problem. Ground connections and ground management is a whole other topic, but certainly still a lot of problems with that. How many people have had a problem due to a bad ground? A few people. Fuel system leaks. How many people have filled up their brand new Motorglider and seen fuel flowing out of all conceivable orifices? Yeah. Fabrication not testing the stuff properly, that's endemic, especially with using non-standard plumbing, non-standard connectors, and then not testing it properly. So some stats here, just to put this in perspective. So everybody knows who Jean-Marie Clement is? Dancing with the Wind, very famous wave pilot. So he has a Ford DM. He's 22 years old. So some of the stuff you might think, well, it's improved since then, but we'll talk about that. So he's got 3,640 hours and 880 launches on his machine. He's typically launching and running the motor for a long time because he's going to a wave. So his original Rotax went 95 hours, including one complete rebuild, before he gave up and replaced it with a Solo. The Solo has had 2 complete rebuilds and is failed again in his most recent flight. One failure per 2.8 hours of operation or per 18 launches. Right? So, not Toyota-like. So just quickly, some interesting things. There's actually 4 gentlemen just sent me an email saying, please update your slides. 49, I have to do it, but anyway. 22 failures where you could continue the flight to the nearest airport, but you didn't want to just ignore it. 4 main belt breaks, 1 muffler spring, the support broken, muffler separated, and fell into engine compartment. Anybody here had that happen? No? How many people have had the exhaust mount, the exhaust crack right near the beginning of the muffler? Nobody? Yeah, okay, so if that happens and the crack propagates, the muffler comes off. Where does it go? Well, you not only now have hot exhaust gas, reduction of power, you have a red hot muffler bouncing around in there. So it's really a problem when the stuff isn't well supported and it can fall off when you have a failure like that. 12 ignition cables melted down for connector damage. A lot of these high vibration engines, the connector, there's so much vibration, you think about that thing shaking back and forth. Well, the connector that's used for the spark plug has a little clip on it, right? It's 2 little wires like a spring. You put it on, it goes clip. You know, you hear the click, right? You know what I mean? If you shake that thing violently back and forth the way these engines do, it wears, it frets the aluminum, and it destroys the spring. Presently, it's loose. Now you have arcing and more destruction there. Check under your spark plugs and see if you see any suspicious black oxide. If so, you might want to do something about your spark plug connections. He's had a lot of trouble with that. Anybody else here had trouble with that? A few people? No. 6 propeller stop failures. How many people have had problems with propeller stops and problems with automatic propeller braking systems? Yeah. Here's a litany of destruction. Fuel tank issues were quite a problem with this. I think that's been greatly improved in recent years, but it continues to be a problem. So what about electric propulsion? What could possibly go wrong? The engineering of an electric propulsion system is not trivial. First of all, when you think of a battery, it's not just a bunch of cells. You have to have the battery management system, you have to have heating, you have to have cooling, you have to monitor each cell, and there's a lot of complexity in there. Charging, you have to have a cell balancing system in the BMS, protection from overcharge, but also protection from over-discharge. If you discharge a lithium-ion cell, for example, below whatever it is, 3 volts, you get to throw it away and replace it. Fire protection is important, and glider pilot protection is perhaps more important. So, this is not a joke. Glider pilots will abuse anything that is removable from the aircraft. They will take the battery and accidentally drop it onto hardtop. They will give it the giant heave-ho in the back of the vehicle. And so you have to design this stuff to be robust in the face of abuse, because it will get abused. So that's an issue. The motor, cooling is a big issue. If the motor is on a pylon, it's in the airstream, it's not too big a problem. The FES can have problems with cooling. Power electronics require cooling. And optionally, you've got, like in the Ataris, pylon extension, engine bay doors, prop centering mechanisms. All of this is a lot of complexity. And it doesn't take but the tiniest little thing to be wrong, and all of a sudden you got a big problem with things. All of these pieces have to be integrated, and present it to the pilot in a sensible fashion and monitor it and control it. So you have a big issue with having a proper control system sitting on top of all of these pieces. If somebody tries to make a propulsion system with a bunch of off-the-shelf parts, you have a real problem because every motor is a little bit different and every battery system is a little bit different, and it may not plug and play. And so that can cause a lot of problems. In the case of the Antares, they had a lot of money at the beginning of the project, and so the motor and battery system and propulsion, the controller for the motor were all designed as one unit, so they match and you don't have that set of problems. There are plenty of other ones. So my experience with the 20E, I just looked at the logs. So 1,350 hours, 61,000 cross-country miles, 11 years of operation. I'm typically running the engines probably actually less than 4 minutes. 4.5 minutes, I just looked at the log for the last flight. 4.5 minutes is from roll, starting the roll to shut down at 1,500 feet or something like that. But usually I shut the thing down around 1,000 feet. So. 168 self-launches, because in contests I usually take tows. It's safer to be doing the same thing as everybody else and not something different. 103 air restarts for a total of 271 runs of the engine, not counting ground runs and things like that. 22 failures in 37.5 hours of motor time. This motor time is logged in a funny way. It's not like a Hobbs meter. I think they're including the time I'm using it to taxi, which is not hugely stressful. So these numbers, if you try and it doesn't add up because the taxi time is included in that number. Some of the failures were not particularly exciting. I mean, you have a thermal fuse fail. Well, you're not going to fly it tomorrow, but it's not going to cause a huge problem right now. And I've been very, very fortunate with this aircraft. The one fire that I had and the numerous times where I pressed the handle forward and got no propulsion all happened on the ground. So let's hope that continues because could have been otherwise. So anyway, breaking that down, 1.7 hours or 12.3 motor runs per failure. And if you compare that to Jean-Marie's experience, it's in the same ballpark, which is to say neither is acceptable. And yeah, still haven't found a Toyota. Small electrofloaters. Again, these things are non-trivial. It's not so easy. Anybody recognize this one? No. 787 fire that happened in my hometown. The 787, this was 7 years ago, January, I guess. And the 787 fleet was grounded while they redesigned the thing to make it less likely to catch fire and also to cause less damage when it did catch fire. So it's not a trivial thing to design one of these things. Obviously, they spent a lot of time and money on designing that, and they still ended up with fires in a certificated aircraft. Everybody's seen this one, right? Yeah? So there have been, I had 3, but somebody corrected me and said, no, 4 fires with the original battery pack on the FES system. And that was a combination of fabrication problems, design problems, and pilot abuse. And so you can discuss whether or not the pilot abuse is the pilot's fault, but the reality is, as a designer, if you design it to be glider pilot proof, then you get this, right? And to my knowledge, there have not been any further fires since Luca re-engineered that stuff. To my knowledge, yeah. Okay, what happened here? Anybody know this accident? Yeah. So the real cause of this accident was, once again, the pilot trusted the motor. But a contributing factor is that the controller still indicated he had 20% battery capacity left. And this kind of thing and associated just random other electrical failures can cause propulsion system failures. Yeah, this I got to tell you, you pay $250,000 for one of these nice toys and you strap it in and you're all ready to go and you push the handle forward and bang! Doesn't sound right. You turn it off. Go back and look at the engine bay and it's filled with soot. If you look carefully, that's hand-built with perf board. designed. The Antares is interesting because the really hard stuff was done by real experts, beautifully done. All the stuff around the edges, not so much. I'm going to talk about what that means in terms of the way we do engineering and some ideas for possible. So these are some other Langenhauser horrors. This and this, you see how that's discolored? That's severe component overheating due to bad design, which of course caused the failure that caused me to go digging and find this. And in this one, well, okay, why? We all want Toyotas. Okay, I can continue with this stuff for days and days and days. I have really quite some file, and thanks to all of you that sent me stuff. But the purpose of this is just to illustrate that there are issues out there, and that the same issues occur across a lot of different manufacturers. Right? We've touched on stuff that occurred across like 6 different manufacturers in these slides. So I'm not picking on anybody. It's an industry-wide problem, and I hope we can do things to improve the situation. So at the top level, why and how do these things keep happening? One, certification process, we'll talk about that. The people doing the engineering, we'll talk about that. And the processes that people are using. Ongoing maintenance, and especially older aircraft, cause a lot of problems, but part of the reason that happens is we don't have good, sensible, manufacturer-supported consolidated inspection checklists, which are regularly updated as we have real-life experience, right? Even for the older aircraft. News groups do a great job of disseminating information, but to get it organized so that if you're going to go buy a new XYZ, you can go, get the chart, inspect it. Similarly, component replacement schedules, especially as we find that certain part only lasts a certain number of hours. The manufacturers, it would be really helpful if we could figure out how to do this in an organized, regular, and sanctioned fashion. So, these things are Motorgliders. They're gliders. They're not powered aircraft. And the certification criteria for the motor is like basically non-existent. A lot of the stuff is not covered by certification criteria. Some simple stuff you'd expect: motor out and running, max level sync rate at the yellow triangle. You can do an in-air restart. You really want to be flying in as slow as the blue line? Maybe not. Handling and landing requirements. Fuel storage and plumbing. We've seen all kind of haphazard stuff and lots of problems over the years. The actual wiring harnesses in these aircraft, there are some pretty good standards out there. Dick probably knows better than me about some of this stuff. ASTM, there's a standard for how this is. So it's improved a lot since the days I bought a brand new Level 6 and it shows up with a piece of lamp cord as the battery would be, literally. But it's still not at the level that you are required to certificated aircraft. Electronic design standards is very, very difficult. This turns out to be probably the hardest problem. There are no such things. If you've ever worked for a larger firm that designs electronics, as I have, there's typically a company policy book, which is constantly being updated as the available components and technology changes, more than learning stuff, but just things continually changing. So it's really hard to have standards if everything's in a continual state of flux, which is the case in electronics. But simple things like, if you look at a schematic and you see a capacitor, well, what kind of capacitor? When you build a structure, you have to allow a margin. You don't run the structure at the yield point, right? You have required margins. For electronics, you need to look at the specification of the component and understand that's a maximum, and figure out a safe level of derating. And every different component has different rules for derating. This stuff is very hard to standardize, and again, it's constantly in a state of flux. You see a capacitor in a circuit diagram, there's like 50 different kinds of capacitors, and they all have different characteristics and different required safety considerations. Change management standards. It's not prohibited for a manufacturer to just change a part. For those of us that have done this for more than a week or two, I've had at least one instance I can recall where I I designed something, and during the production process, somebody substituted a component because it should be the same, it's good enough. Caught fire. Fortunately, they caught fire at the manufacturer, not at a customer location or in an aircraft. Another problem is the certification. The authorities do not have practicing engineers. If you're an engineer that got the degree, learned some stuff at school, but never really worked in industry to learn the realities of how you do this stuff, how you manage derating, how do you manage change control, how do you manage testing, and you're not constantly practicing and learning and keeping up on all the available components, what chance do you have of looking at this stuff and figuring out whether it makes sense or not? So the authorities rely on the manufacturers. And as we have seen in the recent headlines, it doesn't always work out so well when the certification authority delegates to the manufacturer, right? There's a lot of pressure on the manufacturers. Again, we're talking about, like, why does this happen, right? Damn customers. Customers are such a pain in the ass, right? And, this is, while you're late and you're trying to finish things, phone is ringing, people are yelling, gotta have my glider for the soaring season, what the hell's going on? All of the glider manufacturers, they're little tiny companies, they have very limited financial resources, and that leads to limited engineering resources, and that leads to limited expertise. So it's very hard to have specialists across all the disciplines that may come into play, especially as you start getting into motor gliders and you have to have all these different disciplines play together. Worries about competition, got to get it out the door before they do. And besides, how hard can it be, right? All we're doing is sticking a motor on a plane. Very often people underestimate the difficulty of technical problems, and that directly leads to overestimating the available skills and applicability, the ability that you have with the people readily at hand. So what happens? You end up using people that are not. All of this contributes to using people that are not completely at the level that you really want to have. And then manufacturers run out of money. Promise new planes, some problems, out of money, try to get by however you can. In the case of 2 of the 4 Langley fires that were on that slide, those parts were engineered by a guy who's not an electrical engineer and is utterly unqualified. Why? Try to get by. So there's a lot of pressure, and this stuff happens in the real world. Who is doing the engineering? Have they done it before? If you're working on a motor control system and you've done a dozen products using brushless DC motors, not a good deal. Never seen one of these things before, it's going to be a little bit difficult. Our plane has decided to lose all my animations. Okay. In every engineering exercise I've ever been involved in across a lot of different industries, the really top engineers get the really hard, sexy stuff. And there's always a few in the back, Joe in the back, I call it. Because how hard can it be? We'll give it to Joe. So you end up, like in the case of the Antares, where you have a lot of very sophisticated stuff that works really well, and silly little power supplies on the side are blowing up because they gave it to Joe in the back and screwed up. So the qualification is really an issue. Again, when people start doing electrical engineering using people that aren't properly trained and with proper amount of industrial experience, you really run into trouble really quick. Perhaps one of the worst problems we have is the lack of qualified reviewers looking at every piece of design. If you do a structural calculation, you have to have a second engineer do it and sign it, right? Yeah. Some production processes, inspector has to come over and verify that the stuff is done correctly, sign a piece of paper, goes to the file, right? But what about all the engineering? Oops. One question you can ask a Motorglider vendor is, have you taken the example system you're trying to sell me and run it through 500 cycles? 500 cycles is a lot of cycles, but if you do that, like if you look at the microswitch example I showed before, that'll fail in 50 cycles. But if you just fly it a few times good enough and ship it, well, you're going to find out when the customer has it. The glider manufacturers have difficulty hiring. I've heard this a million times, and they can't pay competitive salary. If the top engineer comes out, he's going to get a much better offer from Airbus than he is from one of the glider manufacturers. You get people that really love gliding, fortunately, and people that are not getting the offer from Airbus. All right, so some truisms from Dave. When you hear, how hard could it be, running for the hills, it's the most dangerous thing you can ever hear an engineer say. Because it means you're assuming that the problem is not that hard, and you don't know. This is a great quote. You guys know who Mike Hirschberg is? Some of the OSTIV people. So he's the head of what was formerly the American Rotorcraft Society, recently renamed, what is it, the International Vertical Flight Society to accommodate the flying car crowd, right? Anyway, so he made this during a presentation at the last Rotorcraft get-together. I love this. But you can substitute, really, it's not just an aircraft, it's anything. How hard can it be? Yeah. Anybody remember this quote? It's a very serious thing. Understanding what you know and what you don't know is more important than knowing everything, and you certainly are never going to know everything. And our educational systems, the ones I've been exposed to, do not spend a lot of time teaching people that you now know just enough to be dangerous, and you really have to question at each step. Am I about to step off a cliff here? And again, reviewed by qualified set of eyes. This is less expensive, and it's less time to market. Because what happens is if you catch a mistake while it's still a picture on a computer, it's pretty inexpensive to check it, to fix it. If you catch a mistake when you fabricated some prototype stuff, it's already starting to cost some money, right? And if it's at a customer, it's really expensive. When you have problems and all of a sudden stuff starts breaking in the field, very expensive. In software, we try to do code reviews, but one of the most important things that we can do, and I don't know, this is an OSTIV topic to talk about how the certification is handled, but it would be really good to figure out a systemic way to make sure that we start making a practice, seconds to eyes on all this stuff. Get a senior person with the right qualifications to check. And again, it actually saves money. It costs you a little bit of money at that instant, but it's pretty quickly recouped. When I design a piece of electronics, not being a guy that designs day in and day out, I hire somebody to check it, and they usually find a mistake or two. It's a lot less expensive than fixing things in the field because I screwed up. And I'd much rather have my colleague find a problem before it's built than a customer find a problem with something I did. We don't have that mentality in a lot of the engineering world. For those of you that don't know about this, anybody know about the Kitty Hawk implosion? This company, it's one of the fly car crowd. I'll put the link in the presentation when it's online. It's worth reading how, well, Mike Hirschberg's comment is very, very well illustrated by all of the things that went wrong with this company. All right, this is a particular variety. How many people have ever called the manufacturer and got this letter? Never seen that before. Yeah, they're lying. I got to the point where I didn't call, this has happened with multiple manufacturers, I wouldn't call until I had a list of customers that had already complained about the problem. And then I'd get the slide and I'd say, no, here's a list of people that I know that are already complaining about the problem. Now, can we please cut the crap and work on how we're going to fix it? And there'd be a long pause. And then maybe we can make some progress. But it's quite problematic because, we've seen this happen. I don't know why it happens. Is it ego? Is it fear for reputation? Fear of liability? I really don't quite understand it. But it infuriates customers when they get told that, and then they find out, oh yeah, there were 3 others. My buddy that had the fire, that was one of the fires that was in one of the pictures, he got that right, and then he found out there was another one. Really not good. Customers will find out, and they will be very angry, so it's really counterproductive. But this is unfortunately common behavior. So, Now onto the real purpose of the talk. Again, this is like set the stage for what goes on in the real world, and now it's okay. What can we do constructive about it? OSTIV, did I excerpt this correctly? OSTIV has a huge, long purpose statement, but I pulled out the requisite words.
It's relevant.
Encourage and coordinate internationally the science and technology of soaring, design, airworthiness, and operation of gliders of all types. So I think improving design and safety of motorgliders is squarely within the OSTIV mandate. Also, 80% is the number that Stephen D. put on in his presentation of all in aggregate, the gliders being built, 80% of motors. So where it used to be, there were just some crazies like me on the fringe that had them, now it's, and as the numbers go up, this is going to become more and more and more problematic. Or, I don't know, up to the challenge.
Start.
You know, the most important thing we can do is shine a light on the issues. If nobody admits there's a problem, it's really hard to get started and solve. So some ideas about how to shine a light on issues so that we have a consensus that there's a problem and a basis for making progress. So, first idea, let's redo the DeReese survey. It's 12 years old, and let's try and get more detail. Do a broader survey and try and find out, for the people surveyed, did it well or not? Well, fine, yes, but let's have a list of issues that you've encountered and get the details about the making model. And things that we want to know about is it, what kind of caterpillar, fuel system, drivetrain, switches, controller, other design problem, fabrication problem, or both? Vibration related? Is it maintenance related? Because again, in some of these maintenance things, if there's no decent checklist that says you have to check the Framus, and the Framus blows up and the plane catches fire, well, is that the pilot's fault because he didn't read 300 postings on a newsgroup and happened to see the Framus problem? Not really. So there's some things we can do about that. So, for each reported problem, does the submitter recommend that it be added to the daily inspection thing? So, yeah, owners check the plate in your starter motor shaft. And is expected to be common amongst different types. So a lot of the power plants are shared amongst different types, and so we don't want to just have all people for one particular type of wear or something. And kind of along the same vein, shine a light idea number 2 is to create some kind of website where we encourage everybody to report these problems. And it's a leadership challenge, but get all the manufacturers to get on board with this. Say, look, because it helps the manufacturer. Okay, it's embarrassing to admit that the Framus wasn't properly designed and it blows up and catches fire, but it's better to just get it out in the open and figure out how to get it fixed. For everyone, for the manufacturers, long-term reputation and success for the customers. So it's a leadership challenge to get everybody to sign on to that, but it's not craziness, right? Get some dollar prizes for vibration reduction. Organize some sponsored research with dollar prizes for hitting vibration reduction targets for some of the more common vendors with high vibration loads. Research vibration of existing systems with some really good high-speed photography. It'd be really good to see the flexing and flapping, for example, of the pylon and the prop. You get a hell of a lot better load, indication of the load, so you can see that, and it helps with figuring out how we're going to prevent failures in the field. So this is I think, a pretty good research area to be able to do some research on this with high-speed photography and other analysis. Encouraging design standards. So, we can try and say, okay, well, everything has to meet certification requirements. Getting the authorities involved is always a little bit problematic. And if we keep having a lot of problems and the number of motorgliders keeps going up, it will eventually become something that is mandated. You can get everybody to swear off. The LSA example is probably pretty good. Dick has been instrumental in a lot of that standard development. And the manufacturers self-certify and conform to a number of standards. So, all right, aircraft wiring, we mentioned that's one possibility. It's hard to imagine that we need a standard for how not to install a micro switch, but I don't know. Battery systems, There's an FAA circular that starts with this, and it points at the relevant certification documents. The advisory circular says how to show performance, and that leads to the detailed requirements. Strategies and guidelines for vibration resistance. Anything that can be done there to get everybody on the same page. Again, if lots of people are having the same problems, we're really wasting a lot of energy as a collective community. Again, the electronic design thing is quite tough. I'm not quite sure how to do that. We certainly want to make sure that the individuals who are doing design work are properly qualified and that the work is checked. And that if somebody's doing component substitution, they are properly qualified. And somebody checks it, and there's a test applied to the circuit board with the change component. Not just, it's good enough, we change the part and start building stuff and shipping it to customers, which I've seen. Review requirements, anything we can do to improve the culture where engineers understand it's to their advantage to have a colleague find a problem and not a customer find a problem for both design and fabrication. Second set of eyes is a cost-saving measure, not just a safety improvement. Research fire detection systems. So, like my buddy that had the fire, one of the fires, one of the pages, the fire suppression system didn't go off. He didn't get any warning. The tower, he was operating at a tower at the airport, the tower called him and said, "You're on fire." He said, "Oh, that's bad." Pulled the throttle, landed straight ahead. Some guy happened to be nearby, saw it, and had a fire extinguisher, jumped in his truck, drove over there and put out the fire. Otherwise, we'd have another picture like the one in the video. He was pretty lucky, but he didn't get any fire indication. So, it would be perhaps an interesting research topic. How can we reliably detect fire so that the pilot has a bit better chance? Putting out fires is also hard, and fire suppression systems may be an interesting area. A lot of people are doing do-it-yourself systems, but it'd be good to get some guidelines out there, stuff that is tested and works. Training. Everybody knows about this problem. We don't do anything. So same kind of standard curriculum, getting people to focus on planning a landing prior to hooking with the motor, and regular practical checks, decision-making training, planning your takeoffs and building your board point, figuring out at each stage of the process, what are you going to do if the motor fails here, 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 and motor field legs corresponding to that. It's not just for takeoffs, it's also for getting our restarts. We had an accident in Florida like 2 years ago. Guy started his motor on short final, started climbing away, motor quit, overran the field and rolled into a wall, right? So that decision-making isn't being well trained. And especially training about the required inspections and maintenance procedures. Another thing else we could do is start holding a regular Motorglider manufacturer meeting and to try and share safety best practices and also talk about things that went wrong and what they did to fix it. So what we'd be expecting is each manufacturer shares information on failures where they're having in their own testing or with a customer. For each failure, the new design, the procedures they've implemented, process implementation, changes to the design to prevent it from happening again. And then check the ego at the door and let's talk about from everybody what can else be done. Is there a better way to do this? And I'd say glider manufacturers plus people that are manufacturing major components that are integrated need to be included in that process. So, I don't know, lots of help. Questions? Sir?
I'm hoping that one reason you're not getting as much compliance on industry is that there aren't as many fatalities resulting from.
Yeah. Fortunately, most of the problems result in can't go flying today. Not so many of them result in somebody getting hurt. And even when you roll into the wall, sometimes nobody's hurt. It's the bottom of the authorities to concentrate.
I'd just like to make a comment. I do have a
sorry. So he's saying the most reprehensible failure is the failure to test the stuff. So, when you get a brand new motor glider, you fuel it up and motors, fuel starts pouring out of the wings. Probably wasn't tested real well. And a lot of this stuff should have been caught earlier. Next.
I just want to comment, maybe I'm optimistic. This problem has just come to light with Sebastian's articles and your stuff. OSTIV this is what we do. This is what we ask. These mechanisms already exist. We have the Sailplane Development Panel and the Sailplane Manufacturers Association. We already do all this. This is just something we...
Well, we can add, like,
it's easy.
a piece that focuses on
It'll be done.
the motor side.
It will be done, Dave.
Sailplane cockpits are way safer than
Absolutely.
they used to be because of us.
There's a big
This will be safer. And I hope you're volunteering to serve on the Sailplane
What?
Development
And
Panel.
I'm being asked because of my extraordinary diplomatic skills.
At least somebody's got to light the fire.
Maybe I could do this in the summer meeting or something. I don't know.
Can you get the world picture?
I wasn't planning to, but
There's a Sailplane Development Panel before.
Do you publish information about design issues per manufacturer? So if somebody's looking at sailplanes, say,
no, the best thing to do is to look, manufacturers unfortunately don't publish this stuff very well unless it's pretty serious, but there are a lot of really good news groups, some better than others, but like there's an Arcus news group, there's a 26 news group, there's, and getting involved with that stuff and really reading it through and understanding what problems you're likely to get hit by. So it's good. Kevin.
One thing last year that I did to mine and hopefully make it much more reliable over the years, I was at the seniors and asked Russell Brown, who maintains their stuff, about balancing the cars on the DD400. There's not a good way to do it, but what he said made the most difference in their DD1000 is dynamically balancing the propeller. They did it for me one evening there. It took an hour and a half. You could hear the change when the prop was balanced.
Okay, so
I get 300 more RPM on launch.
So to summarize what, in case you couldn't hear, prop balancing is an important contribution to vibration reduction in some air. Other questions? Hopefully I've offended everybody equally. Thanks very much.